Dear students, so let me illustrate how to imagine the geometry of a unit cell. So the atom or molecule or ions are usually spherical in shape. So let me demonstrate with the available fruit. So let it be an atom. So this is one atom. This is the second atom, the third one, the fourth one. I think you will be able to imagine this. So four atoms are in a regular shape. So if I put a boundary, what shape we get? Yes, you are getting a square. So in 3-dimension means we have four more atoms. So the next one, next one, next one, and next one. So now I have 8 pieces of atoms assumed. So these 8 are arranged in a regular pattern. So in what geometry can be assumed? So if you observe this structure from the top angle, and if you put a boundary, you can see the square. And the same way, if you look from the bottom, same square. Look from the front, or look from the back, or look from the right side, or look from the left side, all squares. If 6 squares are joined in this way, what geometry, what shape you will get? Can you imagine? Yes, we get a cubic shape. So in the cube, let's say let it be this a cubic shape. I don't have a cube here. We can imagine this as a cube. So in the cube, this is one atom. This is x-axis. This is y-axis. This is z-axis. X, y, z. This distance A, this distance B, this distance C, and this angle, this angle, this angle, alpha, beta, alpha. In this cubic, or in this arrangement, if you observe the distance, the A, that is this distance, and this distance are the same. That is A equal to B, B equal to A equal to B, B equal to C. So all are same. Similarly, if you observe the angle, so this angle 90 degree, this angle 90 degree, all angles are 90 degree. That means all the angles are 90 degree. Alpha equal to beta equal to gamma, all 90 degree. So if 8 atoms are arranged, if 8 atoms are arranged like this, we get a cubic arrangement. It is not cube, but it looks like a cube. This is one unit cell. In a particular crystal, if I go on arranging the fruits like this in the x-axis, y-axis, and z-axis, imagine thousands and thousands of fruits are arranged like this, we get a crystal structure. So that if 1,000 fruits are arranged like that, if you look into that, that is called the crystal lattice. If you observe only this portion, it is called the unit cell. So the same pattern is repeated in 3-dimension x, y, z axis that constitute the crystal lattice. So if we observe in the crystal lattice the edge length and interfacial angle, we can decide the shape or geometry of the unit cell by observing these angle and these edges. Crystallographers found that crystals contain 7 types of unit cells. 7 types. The model that I showed is cubic. This is one unit cell, cubic. So in cubic unit cell, its length ABC are equal. The interfacial angle alpha equal to beta equal to gamma equal to 90 degree. This gives cubic shape. The other 7, totally there are 7 types. The other 6 are namely cubic, tetragonal, hexagonal, orthorhombic, monoclinic, triclinic, and rhombohedral. So these are the 7 types of unit cells found in different crystals. Let me repeat the names: cubic, tetragonal, hexagonal, orthorhombic, monoclinic, triclinic, rhombohedral. How they differ? Only in these parameters. You can observe these geometries in your textbook. I'll try to show in the next session the geometries of these cubic unit cells. So in these are the 7 types of unit cells found in different crystals. We are going to focus only on the cubic unit cell in our unit. So let me represent the cubic unit cell like this. So you can consider a cube. You can draw a cube like this, one square, next square. If you join the ends, we get a cube. You can assume this is one atom, second atom, third atom, fourth atom, fifth atom, sixth atom, seventh atom, eighth atom. But don't think this way the atoms are present. I showed the fruits as model. They are closely arranged. But in order to imagine the shape, I have drawn like this. So this is called a cubic arrangement. So here atoms are present only at the corners of the shape, If atoms are present only at this is called a lattice point. Each one is called a lattice point. Only one lattice point is present in the unit cell. It is called the primitive unit cell. So there are some modifications in the primitive unit cell. So I am going to represent another cubic unit cell. So here we have 1, 2, 3, 4, 5, 6, 7, 8 corners. One atom may be present here at the middle of the unit cell. This is called the body-centered cubic. This is called the simple cube. So here there is additional lattice point. This is original, in which atoms are present only at the corners. This is called the primitive. Along with the corners, if atoms are present at the middle or at the faces, they are called the non-primitive unit cell. So unit cells, 7 types. These are the names. In the 7 type, we can classify them into 2 types, namely primitive and non-primitive. Travis found that there are about 14 types of unit cells in different crystals. So this is about a unit cell, crystal lattice and coordination number. Vanakkam. I was explaining about unit cell in the previous sessions. Unit cell is a fundamental repeating portion of a crystalline solid. Basic understanding of a unit cell is very much essential to know the crystalline structure. So let me repeat the definition for a unit cell. Unit cell is the basic, fundamental, repeating structural unit of a crystalline solid. What does it mean? A crystalline solid means it consists of, is made up of millions and millions of a unit cell. So this is the fundamental smallest portion. If you understand the structure or arrangement of the atoms or molecules in the unit cell, we can very well understand the crystalline structure. So unit cell is a very important part. So we have to know about the arrangement of the atoms in the unit cell. The arrangement of the atoms in the unit cell can be imagined as a structure or a geometry. So to know about the geometry or structure of an unit cell, I told you we need two parameters. One is the edge length, and another is the interfacial angle. Hope you remember. Let me repeat, no problem. So in a crystal, we have millions and millions of atoms. We have to assume in 3 dimension. 3 dimension means you have to assume in the left, right, top, bottom, front and back. So let me assume one atom at the crystal, at the center of the crystal. You can consider another adjacent atom in the x-axis, and next another adjacent atom in the y-axis, and the next adjacent atom in the z-axis. If you could be able to find out the distance between these two atoms, so let me repeat, the distance between these two atoms in the x-axis, in the y-axis, in the z-axis, it is the edge length. Edge length is this. So next one is the interfacial angle. If we could be able to find out the angle between atoms in x and y axis, y and z axis, z and the x axis, these are called interfacial angle. By measuring these two parameters, we can know, we can imagine a particular geometry to the unit cell. Crystallographers who analyze the structure of crystals are called crystallographers. Identify different types of unit cells which differ in the edge length and the angle. The unit cells are classified into 2 types. Yesterday itself I told you, one is primitive and another is non-primitive. What is the difference? Primitive unit cell means we have atoms. Atoms can be considered as lattice points. Only one type of atoms. Atoms are present in one kind of lattice point only, means it is called a primitive. I will explain you later. So say if in a geometry, if atoms are present only at the corners, it is called a primitive unit cell. Along with the corner atoms, along with the corner position, if atoms are present in additional lattice points can be face center or at the body center. I will explain you later. If additional lattice points are present along with the corners, it is called the non-primitive. There are 2 types, primitive and non-primitive unit cells. Crystallographers identified 7 types of primitive unit cells. 7 types. They are called, yesterday I told you, cubic unit cell. Second is tetragonal unit cell. Third is hexagonal unit cell. Fourth is rhombic unit cell. Just try to know the names. Next is monoclinic. Next is a triclinic. 1, 2, 3, 4, 5, 6. The last is rhombohedral. But in our unit, we are going to concentrate only on the clinic. Anyway, these 7 primitive unit cells differ, remember, in the edge length and in the angle. What about non-primitive? Bravis identified 14 crystal system. 14 crystal system. So this cubic has two other non-primitive. What is it? See, let me illustrate. So let me consider a cubic shape. This is only imaginary, a cubic arrangement. If atoms are present at the 8 corners. So these are called the corner atoms. This is cubic shape. This is cubic. Atoms are present only at the corners. So this is primitive. If an atom is present at the body center, So this is present. I will show you again with a model. So now consider at the center. So this atom is present at the center of these 4 atoms at the bottom and these 4 atoms at the top. This is called the body center. So this is an additional point along with the corners. So this one is primitive, simple cubic. If an atom is present in an additional point like at the body center, it comes under non-primitive. See, there is one more non-primitive in the cubic. So this is again simple cubic, primitive. So you can assume phases. So this cube has 6 faces. Can you identify? See the face. This is a face at the top. This is the second face at the bottom. This is the third face in the left side. This is the 4th face present in the right side. Top, bottom, left, right. What are the 2 other faces? Yes. So this is the face present behind, present at the back. This is the face present at the front. So we have 6 faces. If an atom is present in between these 4 atoms, so this is called an atom at the face center. This is an additional point. So one more atom, the face at the bottom. One more atom, face in the right side. One more atom, face center of the left face. One more atom, the face present behind, back side. This is 1. And face present in the front. So we have 6 additional atoms at the 6 faces. This is non-primitive. So this is non-primitive. So see, this is primitive having atoms only at the corners. If additional points are present, it is called a non-primitive. So there are 7 primitive unit cells. In the primitive unit cells, additional points if present, they are called a non-primitive. Bragg has identified 14 crystal structures. I will show you in a picture. So unit cell, 14 types of unit cells, including primitive and non-primitive. So I will explain you with a chart.